Hi, I'm Lei Fan. I'm a student at Northwestern University. My advisor is Professor Ying Wu. Today, I would like to give a presentation of our recent paper, Avoiding Lingering in Learning Active Recognition by Adversarial Disturbance. First, I want to briefly introduce the task of active recognition. As we could see from the name, it is the opposite of passive recognition. Instead of passively taking input images, the active recognition agent is allowed to actively adjust its viewing positions for better recognition performance. We give two illustrative examples of agent doing active object recognition and active scene recognition. In other words, the agent needs two modules to achieve active recognition: the recognizer to give the final class prediction, the policy part to choose the next action to take. An effective action could lead to a more discriminative view to classify the target object. However, the training of two modules together leads to a joint learning problem. Here, we give an example of potential phenomenon happening during the joint learning process. In this example, we want to learn an agent to actively recognize apples. The agent can only see one side of an apple at each time step, and the side of an apple could be either red or green. Suppose we only have apples with at least one red side in our training data. The agent could converge to a specific solution. Like the recognizer can only recognize the red side as apple, and the policy only learn how to turn the camera towards the red side. The specific policy could achieve the maximum accuracy on the training set, as the agent always finds the red side and correctly recognizes it as apple. However, this is not what we want. The recognizer is not sufficiently trained for the green side. If we have a totally green apple during testing, the active recognition agent fails. We call this phenomenon as lingering in our paper, since the agent stops taking challenging views during training. Here, we show the visiting frequency of each view if we do not resolve the lingering issue. As we could see, the visiting frequency is highly imbalanced during training. The recognizer could be insufficiently trained towards some views. Our insight is straightforward. We could continuously perturb the policy during training to avoid the agent from falling into a specific solution. For better perturbations, we model it with another adversarial policy. The adversarial policy, on the other hand, is rewarded when the agent fails to recognize the target object. During training, the adversarial policy would intelligently choose challenging views for the recognition. In other words, the recognizer and the major policy could be more thoroughly trained. We conduct our experiments on both active object recognition and active scene recognition. Compared to other training methods, the proposed method solving the lingering issue could achieve an increase of accuracy at different time steps. We here provide an example of our recognition method on the dataset of ShapeNet. Thanks for listening. I would be happy to take any questions. And for more details, please refer to our paper.